Welcome you all. In this session we are going to discuss about peak voltmeters. Outcome: after successful completion of the session, the student would able to explain the principle and operation of peak voltmeters. Passive circuits are not very frequently used these days for measurement of peak values of AC or impulse voltages. The development of fully integrated operational amplifiers and other electronic equipments have made it possible to sample and hold such voltages and thus make measurements, and therefore have replaced the conventional passive circuits. So this is the circuit of peak voltmeter. Here you can see two capacitors C1 and C2. It acts like a capacitive dividers, and the voltage to be measured can be measured with the help of a voltmeter that placed across this load. Suppose R2 and RD are not present and supply voltage is V, then the voltage across the storage capacitor will equal to be the peak value of voltage across C2, assuming voltage drop across the diode to be small. The voltage could be measured by an electrostatic voltmeter or other suitable voltmeters with very high input impedance. If the reverse current through the diode is very small and the discharge time constant of storage capacitor very large, the storage capacitor will not discharge significantly for a long time, and hence it will hold the voltage to its value for a long time. If now V is decreased, the voltage V2 decreases proportionally, and since now the voltage across C2 is smaller than the voltage across CS, which is already charged, therefore the diode does not conduct, and also the voltage across the capacitor does not flow the voltage across C2. Hence, a discharge resistor RD must be introduced into the circuit so that the voltage across the capacitor CS flows the voltage across C2. From measurement point of view, it is desirable that the quantity to be measured should be indicated by meter within a few seconds, and hence RD is chosen such that RDCS is equal to 1 second. As a result of this, the following errors are introduced. With the connection of RD, the voltage across CS will decrease continuously even when the input voltage is kept constant. Also, it will discharge the capacitor C2, and mean potential of V2 will gain a negative DC component. Hence, a leakage resistor R2 must be inserted in parallel with C2 to equalize the unipolar discharge current. The cable capacitance comes parallel with the capacitance C2, which is usually changed in steps if the voltage to be measured is changed. A change of length of cable would thus require to recalibration of the system. The coaxial cable picks up the electrostatic field and thus prevents the penetration of field to core of the conductor. Thank you.